So this is the video for the practice questions for organic chemistry. So we're just gonna go through this quickly. This will basically be a majority of the test. Most of the theory questions will be SDSC projects, hopefully, that we're gonna do this week. But just naming will be on a test. So benzene, we know that we can draw the benzene molecule like this. Don't forget to put the double bonds. Those are important for benzene. Otherwise, that's just a cyclohexane. Again, toluene is just a benzene ring with a methyl group. It doesn't have to be sticking out of the top. All the carbons are equal. You can, from any carbon, you basically draw in CH3. Phenol is again benzene. Start off, and then out of somewhere you stick an OH group. Trinitrotoluene. This one is interesting. I will not ask you this question on a test, but that's just to know that the importance of organic compounds. Trinitrotoluene is the full form of TNT, the explosive. So again, you're going to have toluene, so CH3, and then trinitro. So there's three nitro groups. Nitro groups is a functional group that we haven't talked about, but nitro groups is an NO2 functional group. Writing O2N versus NO2 is the same thing. It's just to show that that carbon atom is connected to the nitrogen, which is connected to two oxygen atoms. So that's trinitrotoluene, or the famous explosive TNT. All right, now we're getting into the functional groups. So there's a fairly straightforward method in order to read these things and name them. So first we kind of identify the functional group. OL, we know it's an alcohol, and we know that it's an OH group, octan 4. So we're going to put 8 carbons, 3, 4, 5, 6, 7, 8. On the fourth carbon, we're going to throw an alcohol, so 1, 2, 3, 4, OH. And then we're going to fill in our hydrogens. So 1 bond, 3 hydrogens, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 3 bonds here, 1, 2, 3, so 1 hydrogen, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 1 bond makes 3 hydrogens, because they always have to add up to 4. And that is octan 4 all. Heptane. Heptane is no functional group, is just an alkane. So this is just 7 carbons. 5, 6, 7. And then you fill in the hydrogens according to the number of bonds. Very, hopefully, straightforward. The end ones will have CH3, the middle ones will have CH2, because they all have 2 bonds. Non-3-ene. So again, non meaning 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have a functional group, but we do have an ene at the third carbon. So 1, 2, 3 after the third carbon, there's a double bond. And then that's non-3-ene, and we fill in our hydrogens. 1 bond, 3 hydrogens, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens, 2 bonds, 2 hydrogens. This carbon has 1, 2, 3 bonds, so 1 hydrogen. This carbon has 1, 2, 3 bonds, so 1 hydrogen. 2 hydrogens, 3 hydrogens. That's non-3-ene. Continuing on, we have butanal. So al stands for the aldehyde, which means I know I have a double bond O at the end of my compound, or the beginning. We'll put it at the end. So 1, 2, 3, 4 carbons for butan. Then we have a double bond O at the end. So this carbon has 1, 2, 3, so 1 more hydrogen. And then we just add our hydrogens. 2 hydrogens, 2 hydrogens, 3 hydrogens. Hopefully we're good as to how to add hydrogens to a compound. You just, again, count the number of bonds, do 4 minus that, and that's how many hydrogens that carbon has. Pentanoic acid, again, identify the functional group as a carboxylic acid, so it's at the end, and we know it has to have a double bond O. This is what the end of the molecule looks like. So pentan is 5 carbons, add the functional group at the end. This carbon already has 1, 2, 3, 4 bonds, so no more hydrogens, but the rest of them have 2, 2, 2, and this one has 1 bond, so 3 hydrogens, and that's pentanoic acid. Hexan 2-one. One is the ketone functional group, so I have a C double bond O not at the end of my molecule, so somewhere in the middle. Hexane is 1, 2, 3, 4, 5, 6 carbons. 1, 2 second carbon, I have a double bond O. I have H3. Here you'll notice that I have 1, 2, 3, 4 bonds, so there's no hydrogens on that carbon, but the rest of them H2, 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 H3, whoops, 3. That's hexane 2O. Methanamine, methane, again, amine, identify the functional group is a NH2. Methane standing for 1 carbon. Then you attach NH2. This has only 1 bond, so 3 hydrogens. That's methanamine. But2-ine. Ine stands the alkyne functional group, so there's a triple bond at this after the second carbon in a 4-carbon chain because there's a but. So 1, 2 carbon, 3, so H3. This has 4 bonds. This has 4 bonds, so we're all good. This is another CH3. This is but2-ine. Okay, just 3 more. Oh, that was quick. Well, these ones are a bit trickier, so we'll spend a little bit more time on them. We know that butanoate came, the O8 ending stands for ester, so it came from 2 parts. It came from an acid bit, and this is the alcohol bit. So we start off by writing the acid. So butanoate, meaning there was 4 carbons in our acid, and the way we identify the acid is that it had a double bond O. So we're going to add our hydrogens here, H2, H2. And then here, we're going to connect the alcohol. So the alcohol would be O, and then there's 1 carbon because it's a methyl. So this is the acid bit, acid for the butanoate, and this is the alcohol bit for the methyl. Right? So that's how we put those together. So we're going to just look like what it looks like if it's the opposite. Here again, start with the acid. We have methanoate, so that's 1 carbon with the acid functional group. This has 3 bonds, so if we have to complete our hydrogens, we have to add 1 hydrogen. Again, I don't really need this until later. And then I have to add a butyl, which came from my alcohol, so I put the O, and then the CH2, 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 CH3 comes after. 4 carbons here because it's a butyl connected to the alcohol. And again, the CH2, 2, 2, and 3 I got from just putting a carbon chain and filling in my hydrogens, just like I did over here for this half. Right, so that's butyl methanoate. Methylpropanamide, so this is very similar to a ester, an O8 ester, except it's an amide. So again, start with the amide part, propanamide. So 3 carbons followed by the double bond O. This half is the same. You add in your hydrogens. And then we have a methyl that came from an amine. So methanamine is what I had. So I have to do a NHCH3. Was this part over here is my methylamine. Here's my propanoic acid. I put those together. I get methylpropanamide. So that was the practice. Again, if you don't have, if you're slightly confused on where they came from, just make sure to write down what the answers are. That's very important. And make sure you at least kind of see where I'm getting the number of carbons, because on the test, the only thing the only thing I can change is the number of carbons. So instead of methylpropanamide, I'm going to give you propylmethanamide, and you just have to know that if it was propylmethanamide, the carboxylic acid part has only 1 carbon, and the amine part, so it's nitrogen. So the carboxylic acid connected to the nitrogen connected to 3 other carbons. So the other way, if it was propylmethanamide, it would look like this is the methanamide part, and then this is the propyl part, right? So as long as you know how to interchange the number of carbons, which carbons goes where, you should be fine for the test. All right, so I'm signing off. I will do the review as another video, and that's about it for this unit, so to speak. All right, very good. I will see. Have a good rest of the weekend, folks, and I'll see you in class.